Hello and welcome to my channel. Well, the weather hasn't been playing ball over the past month or so, but last Friday we managed to get a clear night and a little bit of imaging time. So I had to go at my first Mosaic. We'll have a go at processing that, and we'll show you the steps we kind of went through to do that. Welcome back to Ardsley Astro. So what is a mosaic and why do we do them? Simply put, a mosaic is multiple images stitched together to form one image. And why do we use them? Basically, and hopefully this will become clear very shortly, if the object that we want to image is too big for the field of view of our camera and telescope combination, then we can use a mosaic to still take an image of that particular object. So last Friday I imaged M31, the Andromeda Galaxy. For my particular camera setup and telescope, it's just too big to fit in the field of view. Fortunately, we could get away with a two-panel mosaic, and I'll go through that process of how we determine how we image that now. So if this is Nina, I've got it installed on this PC just so we can look at the Sky Atlas and the framing wizard, so you can get an idea of why we use a mosaic and how we took the two panels. So as you can see, we've already searched for M31 Andromeda Galaxy. So if I set that to the framing assistant, so now that image is loaded, we've got on the left hand side here, we've got our camera details. So we've got the width in pixels, the height in pixels, the pixel size and the focal length of our telescope. And as you can see, this is Andromeda, and that's how much of it would fit in. If it was flat on, we can obviously rotate the camera and it will just about fit in one frame there. If I rotated the camera around to 100 degrees. But my camera rotation is normally around 245. That's the normal camera rotation. It's just the way that I have the camera inserted. I could rotate it around, but it seems to fit very well with the images that I take for this particular rotation. So to be able to take this image, we end up doing a two-panel mosaic, and that is what the framing assistant brings it out to. Now you can change the overlap in between. You can adjust it. It ends up becoming a very square image, but you can see that it fits in very nicely in the framings very nicely. And that's exactly what I did. So the image is then split into two. We've got our first panel here and then our second panel here, and we can just add them to a target sequence. You can then split them up into two different sequences, and I managed to take about an hour and a half of each one on the same night. So what we have is our two panels. So these are all the frames, the light frames from the first panel. Let's see, we've got 63 of them, and we've got the second panel here, which is 76 of them. I've got a little bit more time on the second one, but there's a lot of clouds in the ends of this one, which we need to do something about. So the first thing we need to do is we need to cull some frames. Load Ardsley Astro. I'm going to use the blink comparator to select the appropriate folder. So we'll start with panel 1. We only want the lights folder. So once the images are loaded, we just need to hit show metrics. Now, as it says, you're going to use all CPU cores, and it may lock up until it finishes. But let it run, and it will come back with some interesting information. So once it's run, we get all this information, and the particular thing I'm bothered about in this is the background. And what I want to do is to drop it so it's just below 0.11, and what it will do is it will get rid of all these frames at the beginning, which there is too much background in. As you can see, we're between 0.1 and 0.11, but we're just dropping all these frames, and we can see whereabouts it's going to drop them from. It's only the beginning frames, so that's fine. So we can simply right click and delete all the flagged frames, and that will delete all the frames from the original folder. So if I look in P1 now and lights, we can see we've only got 54 items now, rather than I think it was 62 or something. Okay, so we've got rid of the frames, the subframes we don't want in the panel 1. We have to do the same with panel 2. So we can close the frame metrics, we can clear the images, we can ignore that error, you can then select the directory again, and we can select our second folder. Images are loaded, so again we do a show metrics and let it process. So with the metrics loaded, again it's exactly the same thing, but what we want to do is to bring down this until it is roughly the same as same level as what we did in the previous section. So again, it looks like these are the frames with all the too much background in them, so we drop below that. All these frames should then be marked, and then we can delete them. So we can close Cyril down now. We don't need that anymore. And what we do need now is Cyril. So we're still on Cyril 1.4 beta 3, and this is the part where what you are supposed to do and the way I do it is different. So because we're doing mosaics, the recommended method of doing it is to manually stack them, which means that you have to manually create a master bias, master dark, master flats, and then manually create a sequence with all the light frames in, start them together. And I want you to use, I think the correct way of doing it, according to Cyril's website, is to include background extraction on every subframe. Let's just do it the easy way. So we've already got our home folder selected. There's Mosaic M31 P1, and we can just use our standard script OSC pre-processing, which will do everything for us. It will stack all the dark frames together, stack all the light frames together, stack all the flat frames together, and all the biases, and calibrate the light images as needed in one script. So if we run that script, that's our first one. And what then we want to do, now we've got a stacked image, if we open that up, M31, this is our stacked image. As you can see, if we expand it, it's still got a large background in it, but the part of the Andromeda Galaxy we want is there. So what we want to do is we want to run a background extraction on this. So if we go to scripts, Python scripts processing, we can use Graxpert to do the background extraction. So let that do the background extraction. There we go. And what we want to then do is save this image into a new folder. So I've created this folder called M31 Mosaic. Obviously we don't want to call it results 4860. So if we call it M31 underscore 1 dot fit and hit save. 32-bit, everything else is fine, that's fine. So it's our first panel image. It's not processed, but that's our first panel image ready for stacking together with the second panel image. So what we then need to do is we need to change the home folder. Select P2, open that as the home folder, and then again exactly the same, run the pre-processing script so it stacks all of our darks and flats and everything else together. The stacking is now finished, so we can then open our final result. And again, it's the same thing. I've put auto structure on just so we can see what's in it, and then we want to run Python scripts, Grexpert, just to do a background extraction. Again, once it's done as background extraction, we then need to save that image, but we want to save it into the second folder with a number 2. The numbering is important for the next part, which is to stitch them together, because we need to create a sequence. If we now change our home folder again, but this time to the Mosaic folder, this is where we can stack them together. First thing we want to do is do a search sequences. So what it will do, it will see that M31_1 is one part of the sequence, and M31_2 is the second part of the sequence. Then the first thing we want to do is to plate solve them, but we want to solve the whole sequence. So when you have a sequence selected, it will give you the image plate solver will give you more options. So you can see we can then solve the entire sequence. I think you can leave all these as defaults and just press OK. That then runs a plate solve on both images. You can then go to registration, because then we need to register the two images together, and this is where we determine our framing method. So we're going to register all 2 images of the sequence. We want framing method to be maximum. We can click estimate, which will then tell us how big our final image will be, in this case 4166 by 5118, which sounds correct for our camera. So we can then register, and then it comes to stacking. So stacking, we want, the only thing you need to change in here, I believe this is all default, but the only thing you need to change is the borders feathering, which is when the 2 images are stuck together, to feather the actual point where they kind of join. And then I normally take normalize on overlays. So if we click start stacking, it will stack 2 images together, and this is our final result. So let's rotate that around. Don't particularly like it that orientation. Let's rotate it around this orientation, and if we run the auto stretch, there are our 2 images joined together. How cool is that? So now we can pretty much process it in exactly the same way as we would a normal image. Before we do that, let's just have a quick look. Can we see any join between the 2? Absolutely not. I don't think we can. No, I think that all looks pretty good. So yeah, we can run through our normal process now. So we can crop the image to get rid of these stacking edges. Let's do a color calibration. We've already the image is also already plate solved inside Cyril, so we can go straight for our spectrophotometric color calibration, and we use the Sony IMX294 because we used as SV Bony 405cc, and we used an SV Bony UV IR block filter, so we can just hit OK on that, and you should see a color shift in here once it's complete. And that looks pretty good, and we can just now process this normal way that we have done with previous images. So I'll take myself off the screen, and we'll see you once the image is finished. final processed image. I don't think that looks too bad. I think that's a very pretty image. The main problem with it is there isn't enough integration time. I literally only took both sets of panels in one night, and I got about an hour and a half on each panel, roughly speaking. With more integration time, we'd get more detail out of it, and we get more of the outer areas. But for a quick mosaic, I think that's come together pretty well. Okay, we'll leave it there for now, and again, thanks very much for watching. Do all the YouTube like and subscribe stuff, and we will catch you in the next one. Ciao for now.